Okay, so I want to explain some terminology to you for conformation. So first is the dihedral angle. The dihedral angle is the angle between two atoms. Okay, so I want you to focus on the blue atoms here, and you're probably thinking, where is the second one? It's at the back. Okay, so here is two carbons, and I have two atoms here just for visualization. I could have two hydrogens, but you know, that's kind of goes into the background. So we'll just have these blue ones so you can kind of focus on what I'm talking about for the different terms. So the dihedral angle is the angle between these two. So right now the angle between these two is 0, right? Because they're right behind each other. Now if I were to move one of these, rotate, you know, one of these atoms, which is what conformation is, because conformation is just the movement of atoms. Okay, you're not breaking anything, you're just rotating them. So now what happens? Now the angle between here and here for this atom, between here, this is going to be 60 degrees. Okay, so now when you bring it down here, it's 60 degrees more, and then here it's going to be 180. So now here you have these two. Yep, there we go. All right, so now we have these two atoms right opposite each other, which is 180 degrees. Okay, so if I rotate it once more, so the angle is 270, but it doesn't matter because the angle is between these two, so we're still 120. Okay, and then again here it's going to be 60. So what kind of a dihedral angle are we looking at? Are we looking at these two atoms? Are we looking at these two? So you focus on what two atoms you want to look at. Okay, because at this time this blue atom and this white one here, they are at 180. Okay, so at any given time, you know, you have to kind of focus and zone in on what are the two atoms you're looking at for the dihedral angle. Okay, now the dihedral angle can be for straight chain compounds as well as for the cyclic compounds. Okay, so in the cyclic compounds we just look at it a little bit different, which I'll show you when we get there, but for right now let's just focus on the straight chain. Okay, so again, dihedral of 0, 60, 120, and then 180. And if you're thinking, why don't we have a 40? Well, you could if you wanted to. Okay, I'm not saying you can't, it's just that, you know, we generally measure in 60s for the conformations we are learning here. Okay, so this was the dihedral angle. Now for the steric strain. Steric strain, or what we call steric hindrance, is the spatial the space that is occupied by the atoms. Okay, so here we have, let's say, these two, which are hydrogens. These two are very small, right? Hydrogen is the smallest atom on the whole periodic table, so it's very small. Then let's pretend that this is going to be iodine, but this is not a very true representation of iodine because iodine is, you know, a huge atom. So if these were two huge atoms, they will occupy a lot of space. Okay, so to show you that kind of spatial thing here, I'm just going to take butene because I have it right here. So here, if you have these two methyl groups, you know, that's a spatial occupation or occupying space. Let me just put it simply. So they're occupying the same space, okay, that we have here, and that is what we call steric tension or steric hindrance. Okay, and that's because they're occupying the same space. So here the steric hindrance is a lot more. If I were to rotate it, now you have a lot more space here. It's just like for yourself, you know, if you were sharing your room with somebody, there's a lot of steric hindrance going on there. Okay, and then finally they have we have what is called the angle strain. Now angle strain is a little bit different than dihedral angle. Okay, dihedral angle is the angle between the two groups. Okay, as I showed you over here, that's dihedral angle. Angle strain has to do with cyclic compounds. Okay, so I'm going to make a separate video for you for the different ring structures that we have, but otherwise if you have something like this, which is a cyclopropane, this is angle strain, okay, or what we call it. And here is cyclopentane, so here is the angle. So which angle is more stressed out? Okay, that is called angle strain. And why would something be stressed out? If something is put against somebody's natural environment, just like for us also. So if you have a particular nature and then you are changing that, or you're putting it in a stressful situation, that's when you have the stress, right? It's the same thing with the atoms. So if they are occurring in their natural state, that's going to be fine. But if you change something from that natural state, it's going to have that stress. Okay, so the angle stress is when something is not in their proper angle, which I'll talk about when we get to the ring structures.